a Newtonian fluid is. So firstly, a Newtonian fluid is a fluid in which the viscous stresses arising from its flow at a very point are linearly proportional to the local strain rate, the rate of change of its deformation over time. That is equivalent to saying those forces are proportional to the rates of change of the fluid's velocity vector as one moves away from the point in question in various directions. More precisely, a fluid is a Newtonian only if the tensors that describe the viscous stress and the strain rate are related by a constant viscosity tensor that does not depend on the stress state and velocity of the flow. If the fluid is also isotropic, which is that its mechanical properties are the same along any direction, the viscosity tensor reduces to two real coefficients describing the fluid's resistance to continue shear deformation and continue compression or expansion respectively. One of the examples of the Newtonian fluid are water and air, which can be assumed to be Newtonian for practical calculation under ordinary conditions. A non-Newtonian fluid is a fluid that does not follow Newton's law of viscosity. Example, constant viscosity independent of stress. In non-Newtonian fluids, viscosity can change when under force to either more liquid or more solid. The more force or the larger force we apply to the oblate on the surface of the oblate, the more the time taken to emerge into the oblate. But the lesser force we use to emerge inside the oblate, the faster the time taken to emerge into the oblate until the bottom of its surfaces.
For the pseudoplastic fluids, it is also referred to as shear thinning fluids. The viscosity of these fluids will decrease with increasing shear rate. For example, a shampoo or similar solutions of high molecular weight substance. At low shear rates, these liquids will experience the formation of shear stress. The shear stress results in the reordering of the molecules in order to reduce the overall stress. This induction of a higher degree of order in the fluid reduces the shear stress and leads to the observed non-proportionality between the shear rate and the shear force.